Hello and welcome back to another episode on Space Door Live. Hey Nick and Terry, how's it going?
Very well.
We're
good. That way.
So good to have you back. Welcome to our audience. Thanks for joining us for another show on the Space Roundup. I think we're actually approaching our third anniversary in a month or two.
Yep.
So still going strong post-COVID. And thank you to all of our listeners who have been joining in since the very start. There have been some changes that I wanted to let you guys know about at Space Door. Unfortunately, we have had to close down Space Door Didcot and combine it with our Oxford store in the covered market. So if you're closer to Oxford, that's very good news for you, because we're going to be bringing some new crazy experiences to Oxford. And spending the next few weeks revamping the Oxford store, making it bigger, making it better than it was, bringing more merch there. So pop down to the Oxford store in the covered market if you can. It's about a 15-minute walk from Oxford Station, right in the centre of town, so you can't miss it if you're in and around Oxford. And we are really looking forward to seeing you guys there.
And there's so much to do in Oxford as well. It's fantastic.
Exactly. I just wanted to say a big thank you to our Didcot community who has supported us over the last 3.5 years. We've had so many customers come in over the last few days, because our last day was Sunday. The build up to Sunday, in terms of the customers who have come and said hi, have bought us flowers and chocolates. It's been overwhelming to see the amount of people who have supported us over the last 3.5 years. Again, we're not going anywhere. We still are around. We're still in Oxford. We're still going to be figuring out a way to continue to support the Didcot community. So please do follow us over here, or join our mailing list. Keep an eye out on our Instagram and Facebook and Twitter, because there are going to be some new experiences coming soon. If you are part of our toddler group, the toddler group is also going to be continuing in a different way, so keep your eyes peeled for that. But yeah, lots more news to come our way regarding Space Door in and around Oxfordshire. But yeah,
I
thank you.
loved it. I love the Oxford store. I mean, the coffee there was great. So if you're doing the same coffee in Oxford, happy days.
We
And the
are
fact is,
actually going to be in coffee in Oxford, yes.
it genuinely, the covered market area, if you don't know Oxford really well, it is, as like I said, right in the centre of town. And if you just fancy a day out in Oxford, and it's a beautiful city anyway, if you've never been, it really is. You've got, a lot of the film set for Harry Potter at some of the university campuses. There's just so much to see and do in and around the Oxford area. And then popping into Space Store, as I said, you're literally right in the centre of town, so you can't miss it. It's absolutely worthwhile. Could not agree more. And given the current economic turmoil that this country is going through, to see that you've managed to rationalise this so well, I think it's brilliant. I think it's a heck of an achievement. So shame about Didcot, as I said, but Oxford, I mean, it's one of the busiest tourist places in the country anyway. So all being well, all good. On to our show.
Yes, I'll let you guys crack on.
Okay,
as you can see, Latch is back. Terry's back. I'm going to try and point in the right direction. All good stuff happening in Northern Ireland. We were talking just in the pre-show about some of the cool stuff that's happening in Northern Ireland at the moment. Terry's got so many stories. If you ever go over to Northern Ireland, go to one of Terry's talks, or go to the Irish Astronomical Association talks, or Queen's University in Belfast. Seriously, he's got so many great stories. Anyway.
Yep. Everybody would be very welcome. First of all, sorry we missed the last one. Circumstances out of our control. So basically, it's great to be back. And we have, once again, some great stories for you. First of all, good old James Webb Space Telescope has stirred the pot again in terms of new results that are making astronomers scratch their heads. And I'm sure there'll be many more to come. This was some results that came from the near-infrared camera on the JWST. And what it discovered was some giant galaxies full of mature red stars that appear to be existing only about 500 to 700 million years after the Big Bang. And that really should not be happening. Other galaxies much older than that had been discovered even by the Hubble Space Telescope, and the James Webb had discovered quite a few others as well. But those were ones that we expected, small blue galaxies. Blue because they're full of very young active stars, which tend to be blue or blue-white in color. Which is what you would expect, because young stars are very active. They're burning up their nuclear material at a great rate, at a furious rate, in fact, and producing very high energy radiation, which appears at the blue end of the spectrum. So it was fascinating to detect galaxies that were just about 300 million years after the Big Bang. Again, JWST was able to reveal these. They are blue in the sense that the light started its journey towards Earth was blue, but due to the red shift, it was well into the infrared by the time it got to Earth and the JWST. And of course, that's what it's designed to do, to detect anything that's radiating in the infrared part of the spectrum. So what's so special about these galaxies? Well, first of all, is the fact that they are so big. They're almost as big as the Milky Way, round about 500 million solar masses. 500 billion solar masses. And they're full of what appear to be older, mature red stars, basically like Betelgeuse. So there's two problems there as far as our understanding of the early universe is concerned. How did galaxies that big form so quickly? And how have these stars reached such a mature age in their lifetime? There's no real explanation for that. We're not 100% sure. When I say we, this is not me. This is the astronomical community. We're not absolutely sure about this. We really need more detailed spectra, and the instruments, spectral instruments on the JWST will be turning to these. But certainly based on all the information we have so far, this is a conundrum. Giant galaxies that have appeared only 500 to 700 million years after the Big Bang, with stars that are already mature in their lifetime. Now, there's another story which we haven't time to cover now, basically that they have discovered that the very, very first stars that formed after what they call the end of the Dark Ages, whenever the universe ceased to be awake to light, and stars were able to form, basically. Some of them are much, much bigger than any stars that we have ever discovered since. Instead of being up to about 100 to perhaps 200 solar masses, some of them are thought to be up to about 1 million solar masses, which is, hard to comprehend. So they would have had an even faster lifetime. They would also have a completely different mixture of elements, because in the Big Bang, only hydrogen and a small amount of helium and a tiny amount of lithium were created. All stars that have formed since then have been enriched by materials produced by the very first generation of stars. So the very first stars only had basically an awful lot of hydrogen, tiny amount of helium, and an even smaller amount of lithium. And while in theory we know the nuclear reactions that would go on there, that's only in theory. So there may be things there that we haven't got quite right, or perhaps our model of what actually happened with the Big Bang and immediately after the Big Bang, and inflation, and the end of the Dark Ages, how that happened and what happened immediately afterwards. This is basically the exciting part of astronomy. We're always discovering things that don't necessarily negate what we know so far, but they make us think about it again, and we see new angles. And I'm sure sooner or later there'll be an explanation for this. But at the moment it is a mystery. How did these big galaxies with the mature red stars form so quickly? So I'm sure you have views on it too, Nick.
Tear up the rule book. It's that simple. I mean, we always knew when James Webb became fully operational, it was going to redefine astronomy and astrophysics as we know it. The fact that literally in its less than its first year of operation, it's managed to, as I said, pretty much tear up the rule book in terms of the time duration for galaxy formation. As you said, these galaxies just shouldn't exist. If the data is correct, if the lifespan, if the period when these are supposed to have formed is correct, you're coming out, as you said, the cosmological dark ages. The elemental breakdown and makeup of these, once we've got detailed spectra on it, and near spec and near cam itself, but you've got near spec, you've got some of the most advanced instrumentation in the world on the James Webb Space Telescope. I think it's only going to get more and more complex. I think they're going to find more galaxies at higher redshifts, again, that shouldn't be there. So something's going to have to give at some point. And there's a whole slew of people. We talked about this briefly on one of the other shows, but there's letters now going into national newspapers from astronomers saying, I can't say the fact that I don't think that the Big Bang is correct, because I will lose my funding, I will lose my career. These are notable professional astronomers saying this, and time again this seems to be the kind of conclusion that everybody's coming to. Now, whether or not, observational evidence and obviously there's mathematics and the data seems to back the Big Bang, and it has backed the Big Bang, for nearly 100 years now, since the time of Edwin Hubble himself. But we're now again turning a new leaf, as it were, and it's almost like 500-600 years ago when we went from the geocentric model to a heliocentric model for the solar system, and everything we understand about galaxies is said from the early 1920s with Hubble and his work at the 100-inch telescope in California. And there are these times in our lifespan that things have to be kind of rewritten, and when it's Occam's razor. You keep thinking, what's going to be the simplest solution? Not chucking dark energy and dark matter and chaos theory and superstring theory, all of this gubbins at it, which mathematically may be fine and may make sense. And I'm not arguing with any of the notable physicists who have come up with all of these phenomenal theories over the past however many decades. But the fact remains that the observational data right now is not backing up some of these theories. It's not backing up what everybody has said was, the incident of the Big Bang occurring at 13.81 billion million years ago. So anyway, it is fascinating. I just think there's more to come, Terry. I don't know what you think.
There's the big issue which would take a whole program to discuss, and that's the Hubble tension, where the two main ways of measuring the rate of expansion of the universe give two close but different answers, and they are getting ever more accurate in the measurements. In other words, the error bars are getting smaller and smaller and smaller, and they do not agree. Basically, one set of figures gives a figure for the Hubble parameter of 67 kiloparsec. Oh, I always get mixed up here. 67 just to give the figure, and the other gives 73. And that seems reasonably close, but as I say, the error bars are now only about 1 or 2 on either side of those. And the more accurate the measurements they get, the more the divergence between the limits of the errors in that. And that's a serious, serious problem for cosmology. And that may well tie into what we understand about what happened at that time.
Absolutely. And the Hubble constant's been, I mean, it was 55, I believe, when it was first
theorized. It used to be,
yeah. So it's changing anyway. And this is the thing, the refinement of the data, as I said, it comes down to any form of observational astronomy. You know, when you get higher quality and better quality instrumentation and optics, you're going to get better and better data. You know, the James Webb hasn't even really, there's been so much focus on the deep extragalactic work. You know, can you imagine when it really starts looking at exoplanets?
Yeah.
And what it's going to start pulling from those? It's going to be, the hot Jupiter notion. It's like, okay, well, how have you got a gas giant that's literally within inside the orbit of Mercury that's still, there's so much.
The figure just came to me there. I was getting a bit mixed up in all the units. The expansion rate is either 67 kilometers per second per megaparsec or 73 kilometers per second per megaparsec. Bit of a mouthful. Sorry about that.
Yeah, but over that kind of distance and those kind of lifespans, that's quite a big shift.
Yeah,
so,
absolutely.
And I said going from 55. Anyway, cracking story. That's one that we're going to be following on more and more over the coming years. I've no doubt. You know, you almost want the James Webb to have a recharge capability at its Lagrange point. Anyway, speaking of outer distant parts of our solar system, Ryugu. So Hayabusa 2 was the follow-on to the very successful but unfortunate ending Hayabusa mission, which was run by JAXA, the Japanese Space Agency, which visited the asteroid Itokawa and was one of the first to do a sample return. Obviously had issues on re-entry, but Hayabusa 2, which launched 2016, 2017, rendezvoused with Hayabusa in 2018, touchdown on the surface, which again is, take it from me, this is an astronomically incredible achievement. To touch down, have a soft landing on something with almost no gravitational field whatsoever, takes some doing. The orbital dynamics behind that and, you know, the whole mechanics of it are astonishing. What's even more astonishing, they not only landed the spacecraft on the surface, but they also put 3 rovers, and the rovers which were named Minerva 2A, 2B, etc., aren't rovers like you would imagine a traditional rover, like a lunar rover or a Martian rover, because the gravity is so weak that had the rovers driven, they'd have driven off the surface. Mm-hmm. They'd have literally taken off in a kind of Donald Campbell in the late 1960s on water kind of way. It would have literally just lifted off from the surface. So they hopped around, and they had these kind of micro reaction systems that allowed them to jump around the surface. When I say jump around, when they jumped, they were in orbit, as it were, or off the surface for 15 minutes at a time. Now, it kind of brings you back to the Rosetta and, you know, the Philae lander on that, and the whole mess with the harpoon and that not working, and that catapulting itself off the surface as well, and then landing pretty much on the other side of the comet. But basically, they were not only imaging, but able to sample the data. The main lander itself and, you know, the core instrumentation on it included a micro impactor as well. Now, the micro impactor was really important because obviously the surface of an asteroid, and this is quite an old asteroid, Ryugu was selected because it was a lot older than Itokawa, and they thought that some of the really interesting organics that we believe helped possibly bring life to this planet, or maybe permeated life throughout the entire universe, we don't know, were found on some meteorites that we've obviously found on Earth. This is one example of it. This is a carbonaceous chondrite, which is known as the Ende, one of the most studied meteorites in existence. Now, when it landed at touchdown, basically this micro impactor enabled it to go beneath the surface. We're only talking about a few centimeters here, but it managed to go beneath the surface. Now, if you think about this entire mission cost less than Cristiano Ronaldo is costing the Saudi Arabians as a football player. I mean, literally end to end, the mission's about $150 million, which is astonishing. So it blasted subsurface, it's got onboard spectrometers, was looking at the chemical composition, etc. Managed to scoop up the samples, lift off from the surface, and then return those samples to Earth. And this is where it really starts to get interesting. So the samples from Ryugu have now been analysed, and yes, they have found prebiotic organic compounds in them, which basically everyone thinks prebiotic and organics, it's life. It's not. The chemical processes can create these, but these are the building blocks, the kind of amino acids and the things that essentially form the building blocks to life. So carbon mixed with nitrogen, mixed with sulfur, mixed with water. There's evidence that this stuff was exposed to running water at some point. And again, you've got to think, where, how? This is an asteroid. It wouldn't have had anywhere near a gravitational capability to support running water. So what was going on in the earliest part of the solar system when the sun was just forming and all the gas giants were basically being blasted out to the outer edge of the solar system, and Jupiter was on its hop in and out of the solar system, and we had the rocky planets again initially forming with no water, and there was all the theories of whether or not it was comets that dumped all the water on the Earth, and potentially could have been asteroids. We do not know, but I just love this, the fact that this incredibly low cost, but I say $150 million, compare that to the Artemis launch. Artemis itself, per launch, is costing the US about $4 billion. The entire project is about $10 to $12 billion. For $150 million, they've managed to take off from a JAXA spaceport, send a spacecraft all the way out to an asteroid, land on the asteroid with a lander, with 3 rovers, do a sample return and collection mission, come back to Earth, bring the samples back. You say about excitement with the James Webb. This is just mind-blowing science. But yes, these organic molecules now are really giving us an insight into potentially where life may have come from. And we've got the OSIRIS-REx samples coming back later this year. That's on its way back. So there's going to be hopefully some cross-comparison. And I think more and more of these asteroid missions moving forward, and potentially comet missions. I know European Space Agency are very keen to do a follow-on to Rosetta. They'd like to sample more and more comets. Obviously, there was an initial excitement about the water on comets, and could the water have been, as I said, the reason why we got so much water on the Earth. You think about the amounts of water in the Pacific Ocean, it's half the planet basically is covered by the Pacific Ocean. That water's got to have come from somewhere. Where that water's come from, there's still no definitive evidence for that. But as I said, looking at these, these are the oldest things we know of. The micro diamonds and the molecules in the pre-solar grains in this, these predate the solar system by 4 billion years. So being able to analyze pristine samples, this is a meteorite that's landed on the Earth and has been, hit the ground, and very rarely, we've had a few instances quite recently with Winchcombe in the UK where, the meteorite, when it's hit the ground, has been recovered really quickly and recovered quite well to enable scientists to do a lot more detailed analysis without potential contamination. But these are absolutely pristine samples coming back from these asteroids. And as I said, hopefully when OSIRIS-REx comes back, the teams at NASA Goddard and Jet Propulsion Laboratory, etc., have been working on the Ryugu samples, and it's tiny samples. Again, going back to what we were saying about instrumentation with the James Webb, the quality of the instrumentation that we have now compared to when the astronauts came back from the moon with the lunar rocks and some of the initial work that was done on those, they're still finding out things 50 years later from the lunar samples. So I can't imagine what we're going to continue to find with this. I don't know what your thoughts are on this, Terry, but it's brilliant.
Yeah, what strikes me is not just the complexity of those molecules, as you can see there from the illustrations, but the variety of them.
Yeah.
The other thing is that, in a way, it's not surprising, because we have discovered these, what we call organic molecules, prebiotic, if you like, on comets as well, and indeed in giant molecular clouds. So the whole of space is infused with these moderately complex molecules, which are basically the building blocks of life. And it really does sort of make us think, how on earth did life on Earth form? Did it form entirely here? From the original idea was the primordial soup of chemicals, which was blasted by lightning flashes, which caused reactions and so on. Or as it now seems, it's much more likely that certainly the building blocks formed elsewhere in space, maybe not even in our solar system, and were brought to Earth either by comets or asteroids or both, and then they developed into the much more complex form of life that we have. And that, of course, is a different issue altogether. These are not life, but they are the building blocks of life. So it's an absolutely fascinating discovery.
It's almost like Fred Hoyle's going to be double vindicated.
Yeah.
Him and his theories on panspermia and like the deposition of life, and you had all the hullabaloo over red rain over India a few decades ago, and obviously Hoyle was a big proponent of steady state theory, which has largely been discredited. But going back to the James Webb story, something's wrong with the Big Bang Theory that we can't explain at the moment. So could be that Fred Hoyle has the final laugh, as it were, on both of these. Just going into the chat, thanks, Chris. Artemis is true. I mean, Artemis per launch is $4 billion, but I mean, Chris has quite rightly put in the chat the cost of Artemis is closer to $40 billion. It's absolutely astronomical if you consider in all of the work that was cancelled with the Orion and Constellation, etc., under the Obama administration, and then the whole rush to get Artemis ready, which was a Trumpian thing, and we're still several years off even an Apollo 8 return style mission. So. Yeah, a lot more spending to come on that one, unfortunately. Anyway, moving on to our next story. Terry, what have we got next?
Yeah, we're coming ever closer back to planet Earth. We started off at the outer limits of the universe, then the asteroid belt, and now we're coming to our nearest planetary neighbour, Venus, which is actually beautifully visible in the evening sky at the moment. We'll mention that a wee bit at the end under looking up. Venus has been described as Earth's evil twin, and I always think that is a terrible slur on Venus. Venus has done nothing whatsoever to us. On the other hand, we have done lots of things to Venus. We have invaded this territory and left our own spacecraft littering its surface. So it may well regard Earth as a polluter, and it's the evil twin. But being more serious, yes, Venus is more or less the same size and same mass as the Earth. It's closer to the sun than we are, and therefore the temperature is hotter. But the interesting thing is it is far, far hotter than it should be, just because it's that bit closer to the sun. And to put it very, very simply, the atmosphere has a lot of carbon dioxide in it. It has had a runaway greenhouse effect, and the temperature on the surface is up to 467 degrees centigrade, which is hot enough to melt lead and tin. As well as carbon dioxide in the atmosphere, there's nitrogen, there's also sulfuric acid, so it actually rains sulfuric acid on Venus, and the pressure of the atmosphere is 90 times that of the pressure of the Earth. So it's evil in the sense that you certainly wouldn't want to go there for your holidays. You wouldn't last too long. Any of the spacecraft that have been sent there have only sent data back for a very limited time, if at all, simply because of the extremes of the conditions there, the temperature, the pressure, the acidity, and so on. However, the Magellan spacecraft, which was launched several decades ago, more than 3 decades ago now, I think, took a lot of readings, both of the atmosphere and radar of the surface, and it discovered a whole lot of features, but the ones that we're most interested in are what are called coronae, circular features. And why are they so interesting? Well, Venus's surface actually is quite unlike that of the Earth. It doesn't have plate tectonics like we do, where giant plates of relatively solid crustal material slide around the surface of the Earth, bump into each other, get dragged under each other, form volcanoes and form earthquakes, as we saw, unfortunately, very violent ones in Turkey recently. Nothing like that happens in Venus, yet nevertheless it has a hot inner core. Now, plate tectonics help to reduce the Earth's temperature by bringing hot material up to the surface, volcanic eruptions, erupting what they call the hot smokers at the bottom of the ocean, where the water comes out from these deep geothermal vents at temperature of 300 to 400 degrees, and so on. So we know roughly how the Earth is losing its heat out into space. But there's no easy way to describe how Venus was or was not losing its internal heat. And that internal heat basically has 2 main sources. First, the original kinetic heat by all the bodies that bombarded the surface of Venus came together to form the planet. And secondly, the decay of radioactive elements, which is still happening here on Earth. So how then is Venus losing its heat? And what the scientists who now reanalyzed the data from Magellan have found that the surface of Venus, the lithosphere or the crust, is a lot thinner where these coronae or circular features are. And they concluded therefore that these are sort of some sort of depression or some sort of a semi-volcanic type feature, and they are occurring over what we would call hot plumes, areas where the hot magma underneath is rising up to the surface and it's escaping from these particular areas. In other areas where the crust of Venus is thicker, then it acts as an insulator and the heat can't escape. So even though that data is about 3 decades old, reanalyzing it and looking at it with sort of new light, I suppose, in terms of what we're finding out about the Earth, even that we've now got an inner core on planet Earth, so we don't even know everything about our own planet. But back to Venus, this does seem to explain how the surface of Venus is gradually being transformed. It is squishy, if you like, it is flexible. And in these areas where the heat is bubbling up to the surface, you get these circular corona features. So Venus is, in many ways, a very, very challenging planet. There's an awful lot that we should learn about it to understand Earth better. It's simply because it is so difficult to study. Putting anything on the surface and expecting it to last for any length of time is really beyond us at the moment. And because of the very opaque atmosphere, you cannot see the surface from any satellite orbiting it. The best we can do is radar observations. There are some suggestions of putting balloons high in the Venusian atmosphere and letting them take samples from the atmosphere. That may or may not happen, but it's not going to be for the next couple of years ago. So Venus, our nearest neighbour, still an awful lot to learn about it. Over to you, Nick.
I think it's also interesting in that I've talked to a few like notable planetary scientists over the years, and they've all said that there's too much emphasis being put on Mars and that we should be going back to Venus and we should be doing more with Venus. Obviously, because we've got, our own issues with climate, change at the moment and are gradually heating Earth. The understanding that we could gain from, looking more in depth at what's happened with Venus, what is happening with Venus. Plus, it's closer, so it's an easier mission in terms of, getting there and back. As you said, landing on the surface, Venera 13 was the one that lasted the longest, and that was about 2 hours, I think, or just over 2 hours. What would be interesting, though, and I've thought about this a lot recently, is synthetic aperture radar, which, if you don't know what that is, it's basically the ability to image things using a radar type array from orbit. It's been used extensively by people like Capella Space, for example, and Oxford Space Systems, who are up near Didcot Harwell area, which is where Space Store was originally kind of incepted at the Electron building at Harwell. They've got some amazing technology, and the Capella Space System can now image from orbit at a 50 centimeter resolution. Now, whilst the Veneras are not, obviously functional and transmitting, they were built so that they would, they get very hot. They're not going to melt down into nothing. They're not going to melt into pools of nothing. So being able to send a SAR imaging system, because obviously you can't see anything on the surface using optical resolutions, but you can use radar, as you said, with Magellan and various other spacecraft. They've been able to image the surface in quite some detail and see these pancake-like formations, these volcanic formations, some of the lava kind of flows that have come out from them in the past. I'd love to see the Venera landing sites from a SAR system, because at 50 centimeter resolution, the Venera spacecraft, they weren't huge, but they were wider than 50 centimeters. And the ability, and they're going to be extremely reflective as well compared to pretty much anything else. And they know roughly where they came down. So I think that'd be fascinating. As you said, putting balloons into the upper atmosphere, or some kind of high altitude pseudo satellite, which is what's kind of becoming more and more prominent. If you've seen the recent Chinese balloons that have been hovering over the United States, yes, they're not weather balloons, people. Let's put it that way. Working with my defense hat on there. It is very, very interesting, and I think there's so much still to learn from Venus, and it's one of those that, because we can't land on it, people don't get excited about it. But I think with modern, Veneras, don't forget, we're looking at the 1970s, 1980s, late 80s, pretty much early 90s, I think was the last time Venera, and that was an orbiting mission anyway. I think it needs to happen again. I think we need to go back to Venus with landers and see, get more surface detail, get more surface information. There's a lot we can study from orbit, but as has been proven with Mars in particular, there's so much more you can get from going on the ground, and we'll talk a bit more about that in a minute. But yeah, it's a fascinating planet. It's just such a shame. If you get a chance to go out and see this evening, we'll talk about this during Look Up, but Venus and Jupiter are very close together. Venus is an absolutely stunning planet to look at. It's really beautiful. And if you've got a telescope with a near infrared filter, what's called an IR742 filter, you can actually, if you're really quite clever, you can see surface detail, because the infrared from the surface actually allows you to, on the night side of Venus, see the surface. I've seen some amazing amateur images of this. Anyway, moving on to our next story, which is me going on a rant. Terry said he's going to go off and have a cup of tea while I rant. I won't rant too much. I've ranted many times about this. Amazon, our favorite delivery company during lockdown and COVID, they do some great stuff. Let's not beat about the bush here. Jeff Bezos is not, he's not Elon Musk. He's done a phenomenal job in terms of, supporting so many things. They had Amazon Smile. They've done a lot of altruistic work. They do some great stuff. But unfortunately, because it's the Klondike up in space right now, and everybody thinks, oh, that's where the gold is, let's go and hunt the gold. Amazon, with Jeff Bezos, one of the richest people in the world, and Elon Musk, the richest person in the world, all both having space companies, they think, well, that's where all the action's at. So Amazon are about to launch Project Kuiper. They've now got FCC, Federal Communications Commission consent, which is US government consent, to launch their own constellation. This is going to add a further 3,236 satellites into low Earth orbit. The issue that they had, so they originally applied for this about 3 years ago. The issue that they initially had was debris and collision avoidance. Now, if I told you, and this is not confidential information, I was in a meeting this week with the Ministry of Defence, and we're doing a lot of work in this area because it impacts the UK government, and it impacts all the governments of the world and all the defence assets around the world, in terms of ISR and being able to observe, nefarious actors, as it were, from orbit, and being able to use spy satellites. It is a big impactor. So we looked at some of the data, and two very notable people who a few years ago were very sceptical about this whole Kessler syndrome happening, one of them being Jonathan McDowell, and another one, Hugh Lewis from the University of Southampton. Hugh Lewis in particular was quite sceptical a few years ago. He's now put out some research which is showing the number of collision avoidance maneuvers which are currently happening. And if I asked you, Terry, to take a pot guess at just how many there are now, would you be able to?
Well, I'd have to guess. Are you talking about the ISS only, or other satellites?
About just Starlink. How many collision avoidance maneuvers Starlink is currently undergoing per month?
Of their own satellites?
Of their own satellites.
Per month? 100?
Yep. 3,500.
Gee.
We are looking at, over a 1 year period, they calculated over 26,000 collision avoidance maneuvers just involving Starlink. Now, over a year. The problem that you've got, he's now extrapolated this data onwards, and the collision avoidance count, once Starlink is fully armed and operational, i.e. they've got their 38,000 satellites, which is what they're intending to put up there, and Kuiper's up there, and whatever China put up there, the numbers of collision avoidance events per year is going to be in the 10 million plus category. Now, whilst artificial intelligence and things like ChatGPT, we've all been exposed to that, and the horrors of Google's version, which got the James Webb data completely wrong. Whilst there are AI systems which can make a best guess, there is no, even notable astronomers are now saying, and notable people in the field of orbital dynamics are saying, it just can't go on. It literally is going to result, and I've been saying this for years, that Kessler is coming. It is coming. Make no bones about it. It's not if, it's when. We're looking at, as I said, between 10 and 100 million collision avoidance maneuvers. Now, at the moment, we've got Russian ASAT debris intercepting the ISS's orbit. We've had to cancel multiple ISS EVAs. Astronauts, it's been too high a risk. The ISS itself could be hit, potentially at any point. There's 128 to 130 million pieces of debris up there already, ranging from the size of a grain of sand up to the size of EnviSat, which is the size of a school bus, all traveling at 8 kilometers a second. And now Amazon are going to stick up a load more. Now, they've mitigated their collision avoidance issues and their debris issues by saying that they're going to have a 7-year lifespan, and they're going to bring them back down, and they're going to put them into a lower orbit. So the initial orbit is going to be anywhere between 365 miles high up to about 390 miles. This is horrendous. This is in like the worst neck of the woods, as it were, in terms of low Earth orbit. If you want to launch a satellite right now, stick it in geostationary, because that's pretty much the only place where you're relatively safe. MEO, GEO, LEO. LEO is just becoming a complete, fish in a barrel storm, as it were. Kuiper, they are already planning 83 launches to get their constellation up, this 3,236 satellite. They're going to be using Bezos's own system, Blue Origin's own New Glenn, potentially, with that. They're going to be using United Launch Alliance, which is Lockheed Martin's collaboration with Boeing and various other groups, and they're going to be using Ariane. So we've not only got 3 at the moment. ULA is not reusable. The Ariane system is not reusable. There's only potentially the Blue Origin itself, which is going to have reusable rockets. So we've also got spent rocket stages. And again, the statistical analysis, there was a really good article on space.com talking about which are the big threats. And one of the key threats, the top 6 that are listed, was mega constellations, of course. But you've also got spent rocket stages. There's loads of them up there. If people don't know, in the 1960s, the US government decided to put up 400,000 needles into space to create a fake ionosphere. They're still up there. Most of this junk that was put up in the 60s is still up there. And we don't know where it is. There are satellites. There was a Russian satellite just after our last show, which literally just got destroyed within the last few minutes. Nobody knows why. Nobody knows what hit it, what happened. It could have been a battery exploding. And this is the other thing. It's not just the collision issues that you've got, where sometimes we've heard apocryphal stories, I don't know how true they are, that Starlink engineers have refused to get out of the way when they're in a potential collision with the European Space Agency, and ESA had to move their satellite. Now it's getting ridiculous. Spent rocket stages, yeah, Chris, it's an absolute issue. Leo, they do deorbit them, but there are still some, Chris, going back to the chat, there are still some from the Russian some of the Russian stages, you can look it up on the space.com article, which is still up there. There are fairings that, when your fairing is deployed, now SpaceX are bringing the fairings back down and capturing the net. We're going back decades now. We're not just talking about recent launches where people have been a lot more conscious as to what they're doing. We're talking about launches going back, we're still finding Apollo stages. We found the Apollo 12 stage after a 40-year round trip to the moon in a very hazardous orbit a few years ago, about 10, 15 years ago, I've forgotten the exact date, JW23. This is only going to get worse. And as I said, the number of collisions is, you look at the data from Lewis et al., it's just going up and up and up. And the problem you've got is that if you try saying this to a lot of the commercial companies, your big guns like your Airbuses, etc., this world, they're not going to want to hear this, because they have a vested interest. They have a contractual vested interest in building lots of satellites, in building large constellations. There's a lot of money involved. So if you start shouting from the rooftops, like I know I do, people like Carolyn Porco is a big proponent of this. I know lots of astronomers have really got quite vociferous about this. But the problem we've got is that it's only the astronomers who seem to be shouting from the rooftops. It's like, oh, our images are being ruined. And we can take that as a given now that wide field survey telescopes are being trashed. Radio astronomy in band 5B is dead because of these constellations. It's getting worse and worse and worse with every week. And whilst you've got phenomenal, incentives like Astroscale and JAXA looking at their deorbit mission, yeah, you're going to bring down 1 or 2 satellites potentially with each mission. Musk is putting up, at the moment, he's putting up between 50 and 70 per launch just on a Falcon. Once he gets Starship active, that thing has got a 130-ton to orbit launch capability. He could put hundreds in that thing at a time. And that's exactly what he's going to do. He's going to put hundreds of satellites, and these satellites have anywhere between a 5 to 10% failure rate. Now, yes, they can deorbit, and they're talking about, we can bring them down safely. That's fine. But if there is a collision, you have no idea where this debris is going. And the ASAT tests from the Indians, the Chinese, the Americans, the Russians, some of the orbits for these ASAT tests of debris storms are going up to 2,200 kilometers. That stuff's not coming out of orbit for centuries. So And then the other issue that somebody touched on as well this week, we're again talking to the Ministry of Defence and various other organisations, is the impact of if you've got that many objects coming out of orbit and they're made out of aluminium and they've got cobalt and lithium and various other things in their batteries, what the heck is that doing to the upper atmosphere? You know, it may not be causing a major problem, but it's not good. It's really, really not good. Chris is saying Elon isn't the richest now. Peter Beck agrees. Yes, this is the thing. Rocket labs. There are some of the big rocket companies, and you know you've got to remember that science is going to suffer here. Our ability to do climate monitoring is going to suffer. Our ability to do communications is going to suffer. Our banking is going to suffer. You know, they've estimated that the impact of a full-blown Kessler syndrome would cost the global economy anywhere upwards of $5 trillion. That's going to make COVID look like, you lost 50p down the sofa. It's bad. So there you go, rant over. Vermin of the skies, Asteroids.
I
Now,
see Mike, a friend of mine, that yes, indeed, used to hear of the asteroids were the vermin of the skies, but this is very true. The other thing is that they're only detecting objects down to roughly the size of a matchbox, unless
5 centimeters is the smallest you can detect. Yeah.
So the numbers go up exponentially as you decrease the size. So something that half the size of a matchbox can't be tracked, but that will blow anything apart. If
that's
it hits something,
that's 3 centimeters in diameter.
Yeah.
Now, if that was made out of aluminium or a metal,
if that hits the ISS, it'll go straight through it.
Go straight through it. At 8 kilometers a second, that would kill any astronaut on EVA. And this is the thing, nobody's going to pay any attention. It's like, we talked about Harland and Wolff just before we came on air in Belfast. The arrogance of the Harland and Wolff team, who said the Titanic was unsinkable, meant that they didn't put enough lifeboats on and people died. And this is what's happening now with space. The arrogance of these companies saying, it's not going to happen. I'm going to chuck up as many satellites as I want because I'm going to make loads of money. And let's not beat about the bush here. Look at what Musk has done with Twitter to realize or to understand the mindset of somebody who is now in control of low Earth orbit. Over half of the active satellites in low Earth orbit are Elon Musk. And to compete with them, you've got Jeff Bezos. And to compete with that, what are China going to do? Are China going to go, look at that, 30,000 satellites that are all American? No, they're going to launch their own.
And India.
And it is just, people have
It makes you want to cry.
It's not just it makes you want to cry. I think we've exceeded the tipping point already.
Yeah.
And the impact on science, which is what we love. The ability to visit Venus, the ability to send a spacecraft to Mars, the ability to go back to the moon. Can you imagine if Artemis launches and a piece of debris that like you said, Terry, you can't track. So if you've got, a launch going through and it has to spend some time in low Earth orbit to do a TLI burn before, it goes on, thankfully not too long. But if you've got something, based upon what's in those tanks on the Artemis, second and, third stage, etc., there's still a lot of fuel, still a lot of propellant in those tanks.
Absolutely.
To do TLIs.
The other thing that concerns me is he says these satellites have a lifetime of 7 years. You're going to bring them down. Does that mean he's not going to put any more up?
No, exactly. He's going to put more up.
He's not going to leave that space empty. He's going to want to continue this. So he may well bring them down, but he'll be launching, I would imagine, roughly similar numbers, if not more, up to replace them.
Yeah,
so
and the
that isn't going to improve.
Yeah, you're right.
Crazy.
The altruism argument is ridiculous. The ground stations for Starlink are $499. You're paying $99 a month for the service. Half the world is living on $1 a day.
Yeah.
They can barely afford to feed themselves. So this whole altruism thing, and they talk about, the benefit of Ukraine. Musk didn't even want to do Ukraine. I mean, it's kind of like almost had his hand forced in letting the Ukrainian army do this. And there was all sorts of brouhaha about that. But the issue you've then got is that even if he said, yes, I'm really in support of Ukraine and I'm going to do this and I'm going to allow, then you are weaponizing a civilian and commercial asset. And if you're Vladimir Putin, you're not going to be best pleased about the weaponization of a civilian and commercial asset. And what are you going to do? If you've got the ability to ASAT something out of orbit, you're going to potentially think, well, this is causing me a problem. What am I going to do? And then you've got the rogue actors, as we call them. So your North Koreas of this world, who now have very capable intercontinental ballistic missile launch capability and the ability to put rockets into orbit, missiles into orbit. Now, if you've got half a decent domain knowledge in terms of orbital dynamics, and you're North Korea, who have no satellites in orbit, and you're thinking, I'm not into these sanctions, I'm being repressed, or if you're, some rogue nation where, again, you've got no satellites in orbit, cybercrime, somebody managed to take out the NHS. People managed to take out the post office recently. This is a big issue. Being able to hack a satellite is real. It's happened. There was a competition at DEF CON, hack a sat, and they did it. So it's a bigger picture than most of the public realise. And what we need is a Greta Thunberg or a David Attenborough or Brian Cox, somebody with the gall who's not in the pocket of, I'm not saying any of those people are, they're not, but we need somebody who's not in the pocket of one of the big companies or the big government companies or the big organizations that are hell-bent on just launching as many satellites and building as many as they can, to say, what are you doing? And raise public awareness of this. Because unless the public say, no, this is ridiculous, nothing's going to change. I can shout from the rooftops, Carolyn Porco can shout from the rooftops, you can shout from the rooftops, Terry. Things are not going to change until you've got massive public opinion. And somebody said the other night, I gave a talk about this the other night, and somebody said, we're thinking on climate change, and it's such a big, climate change and plastic in the ocean is a massive issue. But our climate doesn't end at 62 miles above our heads. We're responsible for our planetary system. So we've got to do something about this. We can solve plastic in the oceans. We can remove that. It's only drifting at 4 knots. We could potentially solve climate change if we shut down, a lot of the pollutants that we're putting into the atmosphere. Right now, we have no technical solution anywhere that can remove 128 million pieces of 8 kilometers per second debris out of low Earth orbit.
I hate to have to, I was just going to say, I hate to have to say this, but it may take a loss of life up in space from one of these collisions before people actually wake up to it. Regrettably. But anyway, back to something, also a very interesting subject, and again, right close to us in terms of astronomical distances. It's a Martian version of the Fermi paradox. And Fermi was famous for saying, whenever they were discussing the possibility of extraterrestrial life, and people at the time were thinking that the universe must be full of it, and he said, if the universe is full of these alien space beings, where are they? So the same sort of thing is applying now on Mars. We have been searching for signs of life on Mars for many decades. First of all, the Viking landers, and more recently, the 2 very successful rovers, Curiosity and Perseverance. And all they have managed to find so far are just very, very tiny traces of very simple organic molecules. And even though they are organic, these could very well be geological in origin, so they are not a sign of life at all having ever existed in the past on Mars. Now, we are pretty sure that the conditions for life having existed on Mars are suitable. It had an atmosphere in the past, it had liquid water, running water in considerable amounts, rivers, lakes, and so on in the past. So if there's a good chance that it had life then, why is there no sign that we can detect of it so far? So some scientists recently decided to look at it from a totally different angle, and that is to say, what if our instruments are simply not capable of detecting any life that might be there? So what they did was they tested some samples of soil from an environment on Earth, which they thought might be as close as they could get to the surface of Mars. And it's an area called a red stone, which is a remains of a river delta in the Atacama Desert in Chile. Very high up. Obviously, it still has some atmosphere above it, very, very dry, but it did have water in the past. And they thought that was probably the most similar area on planet Earth to the Jezero crater, where Perseverance is looking for life at the moment. It's exploring the remains of an old river delta on Mars. So what they did was they took the instruments that are similar to the ones that have already been sent to Mars, and other instruments which would be more sensitive and are ones that are being planned to be sent to Mars in the future. And they tasked those instruments with detecting any sign of life, either present or past, in this area in the Atacama Desert. And much to their surprise, they found that those instruments could not detect any life there, except at very, very trace levels. not only life that we know that exists now, in other words, bacteria and other very simple forms of life that are currently alive, extant, if you like, on planet Earth, but what they call the dark biome. In other words, forms of life that existed way back in Earth's past, but no longer exist. They've gone extinct, basically. And they concluded that the instruments that we currently have on Mars and the ones that are being planned to be sent to Mars at the moment have a very, very low chance of detecting any life that's there on Mars, simply because they had a very low success rate of detecting what we know has a life-bearing environment here on Earth. There was certainly, or there is certainly, life even in the Atacama Desert in Chile at altitude about 4,500, 5,000 meters or so. So this does not rule out the possibility of any of those instruments ever detecting life on Mars, but they're saying the chances are simply so low that we shouldn't expect it. The instruments are not sensitive enough. So, as we were talking earlier about Ryugu, the best thing to do is to bring samples back to Earth where they can be analysed in the very best laboratories that we can produce with the very best instrumentation under very tightly controlled conditions. And that is already underway in terms of what instrumentation is already on Mars. So I'm going to hand over to Nick at that stage and he'll take it forward from there.
Well, it's really interesting because you've got like Northern Ireland again, Thales Alenia, who one of the big defence contractors, very heavily involved in some of the work that's been looked at for the sample return laboratory, for example. In my company, we had some involvement, discussions with them about simulations and systems. It will be really important. You're absolutely right, Terry, to get sample return, but I think equally important is boots on the ground. I mean, you only have to look at, going back to Apollo, being able to put boots on the ground transformed our understanding of the moon, being able to collect so much in terms of, don't forget the sample tubes that the rovers have left now are, quite small in comparison. And yes, instrumentation is now so advanced that you only need micrograms of material to be able to detect something. But as you said, if you've got very limited detection capability in certain regions on the Earth, when we know that we've got a very exotic biosphere and, very diverse life here, if you're finding areas like the Atacama Desert where it's almost impossible at high altitude in river deltas to detect any form of life whatsoever, then being able to put boots on the ground. And I still think where these methane hotspots are being detected, both from orbit and from ground-based, the Canada, France, and Hawaii telescope some years ago. And I know the instrumentation on the rovers has struggled with the methane numbers, but these, it's not that it's not happening. They're there. These methane plumes are there. It is in the parts per billion. It is very low. It, to me, indicates we've got to go subsurface. We've got to get either boots on the ground or the ability for something to land in one of these methane hotspots and start drilling and start going down. Now, the issue you've got with rovers, obviously, is the autonomy on that and the ability to have something that can drill down. You only have to look at, what recently happened, on Mars, one of the Mars missions where the drill broke, and it's not easy. That stuff, the surface soil, etc. on Mars is not going to be fun to drill through. Boots on the ground, you've got, somebody who can adapt really, really quickly. And if, going back to Elon Musk, if he were to utilize Starship to put a mission out to Mars, that kind of laboratory that you're talking about, Terry, the capabilities of, you only have to look at Beagle 2 and okay, it wasn't a successful mission in terms of EDL, there were issues with the solar panels deploying, but what they managed to do with the, the spectrometers and the gas chromatograph and all of the instrumentation on Beagle 2 was take something that was formerly the size of a room and get it down to the size of a shoebox. Mm-hmm. On a really, really small land. I mean, the Beagle 2 lander was the size of a coffee table. It's amazing what they managed to do. Now, if you can get that level of sophistication, don't forget Beagle 2 are going back quite a number of years now. If you could to get that level of sophistication on board a laboratory inside a lander that's the size of, what can be fitted into the fairing on a Starship, ended up on Mars, then you can not only do that level of instrumentation in terms of putting instruments on the ground on Mars and being able to put boots on the ground and get people digging or getting, something drilling through into these methane hotspots, but then without having to go all the way back and wait for it to arrive at a lab back on the Earth, you've got the laboratory in situ. And it's almost like Peter Weir and The Martian, where you've got that habitat kind of concept where you're doing real science on the surface of Mars. And I think that's what needs to happen if we're looking at exploration beyond the moon. Yes, use the moon as a test site, set up a test laboratory on the lunar surface to basically do not this kind of science, because it's a very different form of science, but to do, lunar rock analysis on the lunar surface. And yes, we've only got a few, 1.5 second light travel time. So in terms of comms, etc., and sending data back, it's a lot quicker. But to me, that's what's needed. That is really what's needed. Yes, we've got these little samples, and the rover's going to be able to pick them up. And we talked about in previous episodes the sample return mission. Small samples coming back is one thing. Having people there in situ to say, right, what's that? There's something a bit anomalous there. There's something a bit strange there. Or, right, we're in the middle of this methane hotspot. There's something a bit, odd about that region over there. We've got such high resolution data from HiRISE and various other orbiters that there's got to be a way, once we eventually do go to Mars, which may be 10, 15 years away, still, it's still incredibly complex, in terms of, human survivability, in terms of the long duration of the mission, 9 months there, 9 months back, even if you improve the propulsion system, 6 months there, 6 months back, plus, the time that you're waiting for the orbits to realign, unless you've got a much better propulsion system, you're looking at a 2 to 3 year mission at least, which is going to be hard going for anyone. Let's not, again, beat about the bush on this, but I don't know what you think, Terry, but that's what I think needs to happen.
Well, I totally agree with you. I was just going to say there that hopefully we will get some of the Perseverance samples back before then. But the other angle in terms of Elon Musk, you need to start saving up a few dollars to get him to take a sophisticated geochemical laboratory to Mars instead of a paying customer.
I think, the scientific community would almost forgive him for what he's doing in Leo if he was to say, right, I'm going to do this for Mars now. That'd be really, really good. Anyway, moving on to our final bit, which is look up. And you can't have escaped the beautiful conjunctions that we've seen recently, planetary conjunctions. We've been very, very blessed with Venus being so prominent and so bright in the evening skies over the last few months, and Jupiter now coming in very close, and tonight extremely close conjunction. And then I know you didn't get to see them yourself, Terry, but the Northern Lights, you could see it from, I'm in Wiltshire, which is in the south of the UK. You could see it as far south as Dorset, which is literally at the very bottom of the UK. There were, a friend sent me images that from the Dorset Echo, where pictures have been taken in Wareham, and being able to see these red sheets of aurora and the greens. I saw some of the pink last night from here in Wiltshire. It was interesting. It really was. And I talked to the BBC earlier today about it. But what else is it? I mean, Venus and Jupiter are stunning, aren't they, Terry?
Yeah, I'm not too disappointed. It was my birthday yesterday, and I was hoping that not only would we get one of the major launches from Florida, but also that I'd be able to see the Northern Lights, which are pretty well predicted. But I'm not too disappointed. I've been lucky to see actually a display that was far better than that, but several decades ago. But I saw it from my own back garden, where the whole sky was on fire, reds and purples and oranges and yellows, and absolutely amazing. And
is that when the Triffids came down?
That was, anyway, but yes, as you say, the Venus and Jupiter conjunction is at its best tomorrow night. They are getting closer and closer and closer. Basically, Venus is moving out from the sun as we see it in the sky. Jupiter is moving in to pass behind the sun, and tomorrow evening they will pass each other. At their closest, they'll be just over a moon diameter apart, so you won't see them merge into one, as some people have been saying. They'll definitely be visible as two distinct objects. But they are the two brightest objects in the nighttime sky apart from the moon. So Venus much brighter than Jupiter. So just to see the two really bright objects coming together in the evening sky is going to be quite beautiful. And in fact, a couple of days ago, while they were a bit further apart, there was a beautiful crescent moon forming a lovely triangle with them. And I'm sure there's still plenty of photographs of that available on the internet. So the sun is still very active. There's a chance of another aurora tonight, but you will need clear sky, and you will need a good view to the north, and you will need to be well away from any light pollution to see it properly. One thing that we need to stress is that the photographs that people have been posting online and have been shown in the papers and the media are not quite reflective of what you will see with the eye. The imaging system in modern cameras is much more sensitive than the human eye. It's still very much worth looking at. If you see a really good display, it's something that you will never ever forget, but it'll not appear probably quite as bright as those photographs, which basically the CCD imaging is much more effective than the eye. But by all means, go and have a look and hope for the best. Clear sky. If you haven't any in your own back garden and you know there's a clear patch 50 miles away, somewhere where it's going to be dark, it's well worth going along to have a look.
Yeah, the Aurora Predictor seems to indicate that next Sunday, around about March the 6th, 7th time is going to be the best time to look out for it. So, yeah, keep looking north. As you said, get away from any light pollution. Obviously, the moon phase is going to help as well over the coming weeks.
Full moon will be coming up then, roughly, unfortunately.
Just want to reply to Chris in the chat. I need to stop fighting Musk. Chris and I have talked about this probably many, many times. It's not a fight. I admire Musk for his technical capability. Seeing the Falcon Cause landing in parallel is stunning. What he's doing with those rockets is astonishing. But as you quite rightly said there, Chris, and you've hit the nail on the head, exploiting LEO. This is the thing. He's using LEO to obviously fund a lot of the work that he's doing, and he is planning. He's got some really good intentions in many respects, but you only have to look at what's happened with Twitter and the mass sackings of people and the calling people up at Sunday night and they're trying to get his statistics up. There are issues there. Nobody can argue with this. There are lots of insiders who said there are issues. And the concern, I guess, not just myself, but many in the defense industry in particular have got, is that you've got somebody who is literally taking over control of low Earth orbit. With the number of satellites that he's putting up and the potential disruption that can cause, he can almost deny orbits in some respects now, which is, and that's at 3,500, 4,000 satellites in the coming year or so. When he's got 38,000 up there, he's going to have a lot of control over low Earth orbit. So whilst, yes, I do agree, and you look at Starship, he has got some good ideas. And he is a genius. There is no denying that at all. What he's done with Tesla in terms of commercialization of an EV market, and we can argue about cobalt and lithium mining in the Democratic Republic of Congo and everything else that has the horrors of that to the cows come home as well. And what he's done with Hyperloop, again, looks really, really interesting. There's some really smart ideas here. But as I said, the interesting fallout from Twitter is it's given people an insight into, he almost seems very easy to kind of knock off his perch, as it were. And that's really worrying when you've got somebody with so much power and so much money that has so much control over so many things. So it's not a fight, and it's not just Musk I go after. I've gone after OneWeb. I've gone after, it's anyone that's causing disruption to astronomy, disruption to the night sky, disruption to the beauty that we have in the night sky. And yes, you can put sun shields on Starlinks, which Tesla doesn't use. Yeah, it doesn't use any rare metals at all in the batteries at all. Of course, you can put a sun shield on it and out of sight, out of mind, so the public don't see these gigantic trains of satellites going overhead, but the astronomers do. Don't forget, they're looking at instrumentation that can see down to Mag 26, 27. So when you've got 38,000 satellites coming across a 60-degree wide field of view with the Vera Rubin telescope at the Cat Leader Sky Survey, it's a problem. It's a real problem. And nobody can deny that. The radio astronomy impact, Phil Diamond at the SKA has now come out and basically said there is a real radio astronomy impact here with these mega constellations. And like I said, it's not just Musk. The reason people go for Musk is that he's the biggest player. It's like when I worked for Yamaha doing synthesizers years ago, we had an issue with the use of accessibility on our instruments. And the Royal National Institute for the Blind basically said that they were coming after us. And we said, well, why are you coming after us? Roland and all of these other synthesizer companies are doing the same thing. And he said, yeah, but you're the biggest. So we're going to come after you. And this is the thing, is that we've got to take a balance, but he's also got to understand that there are some very big players out there, some very big organizations, and the government's, UK government included, they've invested heavily in OneWeb. So, there's a lot of vested interest there that is silencing and stopping people like myself and various other people, as I said, Carolyn Porco very notably, from raising this as high as it should be. So let's hope things change. I think we've exceeded the tipping point already. I think we've gone beyond it. But let's see. let's see what happens. But thanks, Chris, and always appreciate all of your comments, mate. It's really good to hear from you. So yeah, absolutely. And one last one, any news on Virgin Orbit? Yes, Virgin Orbit. So they worked out that it was a loose issue of a filter on the injection on the second stage, I believe. They're hoping to attempt another launch probably at the back end of this year, maybe early next year. It's again an interesting one because some military satellites were lost on that mission as well. But yeah, let's hope that Virgin Orbit are not finished now, and obviously what's happening in Scotland at the moment is still interesting with Nicola Sturgeon resigning and what may or may not happen with devolution. So let's see how we go. And back to Atch.
Thank you so much, Nick. Thanks, Terry, for another great show. Really enjoyed it. Thanks for touching upon so many topics. We've slightly overrun, so thank you for sticking with us. Thank you, Chris. Thank you, Mike, and thank you to all of our silent listeners who have been tuning in tonight.
It's really appreciated. I always love the questions, and it's great to see regular people coming in and really engaging with the show. So a huge thank you. And there's never any issue with any comments that you make or hopefully what we make, and we're open to discussion. So it's great. So thank you.
I'm not going to add any more fuel to the fire. But I agree with Nick.
Thanks a lot, Terry.
Cheers.
Awesome. Well, we'll see you guys again in March for another epic show of the latest and greatest space news. Please do follow us on Facebook, Instagram, TikTok if you don't already. And stay tuned. Do come and say hi to us in Space to Oxford in the covered market. It'll be lovely to see you guys there if you guys are local. But yeah, look after yourselves. Take care. And we'll be in touch.
Adios. And we've got something special coming in April as well. So stay tuned.
Cheers, guys, everybody.
All right. Take care, guys.
Bye.
Cheers. Bye. Bye.
There's only been about 20 or so recorded falls in British history. So to get one at all is quite rare. To get one that's witnessed is incredibly rare, and then recovered, I mean, this is off the scale rare. It makes it even more interesting in that the meteorite is what's called a carbonaceous chondrite. So these are some of the most primitive materials in the entire universe. Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the Space Stuff.
Adios, amigos.
Bye, all.